Here we'll introduce coordinates and the coordinate plane. But first, let's make sure you're up to speed on using the number line. So of these green points here, which one represents -2.3? If you're not sure, click down here to review. Right, -2.3 is over here. Next, let's move on to coordinates. You actually use coordinates all the time when giving directions. For example, let's say this is a map of a city where each of these gray squares are blocks and the streets pass between them. Your friend wants to go from this green point down here to this orange point up here, which is in the northeast direction according to this compass. So how would you give directions? Well, you could tell them the total distance between the points and then tell them to walk in a specific northeasterly direction. But unless your friend can walk through buildings, these directions would be pretty hard to follow. Another option is to tell them to zigzag around the city until they find their destination, which is not particularly helpful either. Common practice is to tell them to go a certain number of blocks east or west and a certain number of blocks north or south. So in this example, you'd tell your friend to walk 5 blocks east and then 3 blocks north. This idea of saying where a place is by finding its horizontal and vertical position is precisely how we'll talk about coordinates. We'll start with a horizontal number line, which you're already familiar with. The positive direction is to the right, and the negative direction is to the left, kind of like east and west on our city map. And to represent north and south, we'll draw in a vertical number line whose positive direction is up and whose negative direction is down. And what we've drawn here is called the coordinate plane. Let's see how to use it. This point where the lines meet is called the origin, and it's where you'll start when talking about different points. So for example, if I say start at the origin, then go 3 to the right, and then up 4, where do you wind up? Right, if we start at the origin, move right 3, and then up 4, we're at this point over here. On the coordinate plane, every point can be labeled by a pair of numbers, and here's the label for this point, which you can read aloud as 3, 4. This label means that to reach this point from the origin, you need to move +3 in the horizontal direction and then +4 in the vertical direction. Next, see if you can identify which of these points represents 5, 2. If you get stuck, feel free to ask for a hint. Nicely done. 5, 2 means start at the origin, move +5 in the horizontal direction, and then move +2 in the vertical direction. But what about moving left or down? As you might have guessed, that's where negative numbers come in, because those are the negative directions along these number lines. So if you wanted to find the point -2, 3, then again you'd start at the origin, and then you'd move -2 in the horizontal direction, which is 2 to the left, and then you'd move +3 in the vertical direction, so up 3. So this point represents -2, 3. Now which of these purple points represents 4, -6? Excellent. This point down here is 4, -6. Now this horizontal number line is often called the x-axis, so let's label it with an x. And the vertical number line is called the y-axis, so we'll label it with a y. The first number in a point's label is called the x-coordinate. So the x-coordinate of this point down here is 4. And a quick way to see that is to draw a straight line from this point to the x-axis. It hits the x-axis at 4, meaning this point is 4 to the right of the origin. And the y-coordinate of this point is -6, because you had to move down 6 from the origin to get here. A quick way to check that its y-coordinate is -6 is to draw a straight line to the y-axis and see that sure enough it hits the y-axis at -6. So now take a look at this point over here. What are this point's x and y coordinates? You can figure this out by moving horizontally and then vertically from the origin, or you can draw lines connecting this point to the x and y axes and see where they hit. Very well done. Drawing a straight line to the x-axis reveals that this point has an x-coordinate of -5, and drawing a straight line to the y-axis reveals that it has a y-coordinate of -4. So far we've been looking at points whose coordinates are integers, meaning positive or negative whole numbers. So what about other points, like this one over here? To the nearest tenth, what are this point's x and y coordinates? Nicely done. Now the last few questions in this lesson will use this interactive coordinate plane. You can click on different points to see their x and y coordinates. To get started, why don't you click on the point -2, 4. Excellent. Now to make things a little tougher, we've removed all those grid lines. See if you can select a point that's close to 3, -3. Right, 3, -3 is down here. Next, if you look carefully, you can see that every point on the y-axis, which is this vertical axis here, has the exact same x-coordinate. What is that x-coordinate? Exactly. Every point on the y-axis has an x-coordinate of 0, because you don't have to move left or right to get there from the origin. And similarly, every point on the x-axis has a y-coordinate of 0, because you don't have to move up or down. Also, just so you know, the origin, where the x and y axes meet, has the coordinates 0, 0. Okay, next, try selecting a point with a positive x-coordinate and a negative y-coordinate. There are lots of points you can choose from, but just pick one for now. Nicely done. Notice that the x and y axes seem to divide the coordinate plane into 4 regions. We'll come back to these in a later lesson, but for now you can see that any point in this region down here will have a positive x-coordinate and a negative y-coordinate. Now here's your next challenge. Select a point whose x and y coordinates are both positive, meaning it should be up in this region here, but also make sure that the point's y-coordinate is greater than its x-coordinate. For example, this point over here is no good because its x-coordinate, 4, is bigger than its y-coordinate, 1. So try finding a point whose y-coordinate is greater than its x-coordinate. Excellent work. So any point up here has positive x and y coordinates, but for the y-coordinate to be greater than the x-coordinate, the point actually has to be in this region over here. You're really getting the hang of working with x and y coordinates. So let's finish this lesson off with a question that's a lot less tricky when you use the coordinate plane to solve it. Of these 5 points here, which is closest to the origin? You might want to plot these points over here before choosing your answer. Before getting into what the 4 quadrants are, why don't you first use this interactive coordinate plane and click on the point 3, -1. If you'd like to review xy coordinates instead, just click down here. Okay, great. You already know about the coordinate plane. Now if you look at the x-axis and the y-axis, which intersect at the origin, they appear to divide the coordinate plane into a total of 4 regions, which are known as the 4 quadrants. The quadrants are named, appropriately enough, Quadrant I, Quadrant II, Quadrant III, and Quadrant IV. Now Quadrant I is defined as including every point with a positive x-coordinate and a positive y-coordinate. So before we continue, try selecting a point in Quadrant I. Right, so Quadrant I is the top right quadrant, where every point has a positive x-coordinate and a positive y-coordinate. And by the way, this is a Roman numeral 1. You'll usually see the quadrant numbers written using Roman numerals. Now Quadrant II is defined as including every point with a negative x-coordinate and a positive y-coordinate. So try selecting a point in Quadrant II. Exactly, so Quadrant II is the top left quadrant where every point has a negative x-coordinate and a positive y-coordinate. Quadrant III is defined as including every point with a negative x-coordinate as well as a negative y-coordinate. So try selecting a point in Quadrant III. Nicely done. So Quadrant III is the bottom left quadrant where every point has a negative x-coordinate and a negative y-coordinate. The final quadrant, Quadrant IV, includes every point with a positive x-coordinate and a negative y-coordinate. So try selecting a point in Quadrant IV. And so Quadrant IV is the bottom right quadrant where every point has a positive x-coordinate and a negative y-coordinate. So these are the 4 quadrants. Also, the axes themselves are technically not in any of the quadrants. They're the dividing lines between the quadrants. Okay, so to finish off this lesson, try identifying which of these points here are in Quadrant I. More than one of these is correct. Nicely done. And the final question, which of these points are in Quadrant IV? Here you'll discover how to find the midpoint between any 2 points on the coordinate plane. But first, go ahead and identify the point -3.5, 2, or click here to review coordinates instead. Great! Now for any 2 points, the midpoint is the point that's exactly halfway between them. So for these points A and B up here, the midpoint would be right over here. In other words, if you drew a line segment connecting A and B, the midpoint would be halfway along. Next, go ahead and click on the midpoint between the points C and D. Nice, you're really getting the hang of this. Now we've labeled the points -1, 1 and 3, 3. Try clicking on the midpoint between these 2 points. Precisely, this is the midpoint here at 1, 2. Now if you look carefully, you can see that the x-coordinate, 1, is the average of the x-coordinates of the other 2 points, -1 and 3. Also, the y-coordinate of the midpoint, 2, is the average of the y-coordinates of the other 2 points, 1 and 3. So if you want to calculate the precise coordinates of a midpoint between 2 points, you can take the average of their x-coordinates and the average of their y-coordinates. If you're comfortable calculating averages, then click here to continue. Otherwise, you might want to review. Okay, so as we just said, if you want to calculate the precise coordinates of a midpoint, you can find its x-coordinate by averaging the x-coordinates of the 2 points, and you can do the same thing with the y-coordinates to find the midpoint's y-coordinate. Try finding the midpoint between the points -4, 4 and 5, -2. You can enter the midpoint's coordinates over here, or click here if you get stuck. So you found the midpoint between -4, 4 and 5, -2 has the coordinates 0.5, 1. Go ahead and click on 0.5, 1 to see if it really is the midpoint. Sure enough, 0.5, 1 is the midpoint between -4, 4 and 5, -2. So finding the average of the x-coordinates and the average of the y-coordinates will always give you the coordinates of the midpoint. So as a final challenge, suppose I tell you that 2 points have a midpoint at 1, 1, and I also tell you that one of those 2 points is -2, -1. See if you can figure out the coordinates of the other point and enter them here. So you found that 1, 1 is the midpoint between -2, -1 and 4, 3. Go ahead and click on 4, 3 to make sure that's correct. So you were absolutely right. The midpoint between -2, -1 and 4, 3 is 1, 1. So not only do you know how to find the midpoint between any 2 points, but you can also work backwards to figure out those 2 points when you only know one of them and the midpoint. Nicely done.